Hey space fans, and welcome back. Today, we're venturing deep into our solar system to track a fascinating visitor from another star, interstellar comet 2I, Borisov. It has already zipped past Mars and is making its closest approach to the Sun, a point we call perihelion. This isn't just any comet, it's only the second interstellar object we've ever confirmed, and its behavior is keeping astronomers on the very edge of their seats. Will it put on a spectacular show, break apart under the sun's intense heat, or simply continue its journey back into the void? Let's dive into what we know and what might happen next. First, a quick recap on how we found this cosmic wanderer. Back in August 2019, amateur astronomer Gennady Borisov, using his own custom-built telescope in Crimea, spotted something new. At first, it looked like any other comet. But as observatories around the world turned their powerful eyes toward it, they quickly calculated its trajectory. The path was a hyperbola, meaning it was moving way too fast to be gravitationally bound to our sun. This was the smoking gun. It came from interstellar space, a traveler between the stars. Since its discovery, we've been watching it like hawks, gathering every photon of light we can. Now, as it approaches its closest point to the sun, the real drama is unfolding. Its journey through our neighborhood has been anything but quiet, showing bursts of activity and a chemical makeup that's both familiar and strangely alien. So what have we learned as Borisov has gotten closer? Initially, it appeared as a fuzzy blob, but as it neared the sun, the solar heat began to vaporize its icy surface, creating a classic cometary tail. This process, called outgassing, is what makes comets so beautiful. But Borisov's activity has been a bit unusual. It started showing signs of life much earlier and farther from the sun than most of our own comets do. Spectrographs, instruments that break down light into its component colors, have revealed its chemical fingerprint. We've detected cyanide and diatomic carbon, which are pretty standard for comets. However, the real surprise was the detection of an unusually high amount of carbon monoxide. This suggests that Borisov formed in a very different, much colder environment than the comets in our own solar system. It's a direct clue about the conditions in its home star system, wherever that may be. This unique chemistry is a puzzle that scientists are eagerly trying to solve. This brings us to the big question: why is Borisov so important? Well, imagine receiving a package from an unknown country you've never visited. You'd open it carefully, study every detail, trying to learn about where it came from. That's exactly what Borisov is for astronomers. It's a pristine sample from another solar system, delivered right to our doorstep. By studying its composition, we can learn about the building blocks of planets and other parts of our galaxy. Is the chemistry needed for life common everywhere? Or is our solar system special? Borisov offers a direct test. The high carbon monoxide content, for example, supports theories that it formed in the freezing outer reaches of a distant protoplanetary disk, perhaps around a red dwarf star. Another fascinating theory is that it might have been violently ejected from its home system during a chaotic period of planet formation, a cosmic game of billiard balls where this little ice ball was not clean out of its neighborhood. Every observation we make helps us piece together the story of its origin and, by extension, the story of how star systems across the galaxy are born and evolve. Now for the nail-biting part. What happens next as Borisov slingshots around the sun? It's experiencing the most intense heat and gravitational stress of its entire journey through our system. There are a few possibilities. The first, and most exciting for sky watchers, is that it could brighten significantly. The increased heat could trigger a massive outburst of gas and dust, making it a more prominent target for telescopes. However, there's a darker possibility. Comets are often described as dirty snowballs, and they aren't always held together very strongly. The intense solar radiation and gravitational pull could cause Borisov to fracture and disintegrate, breaking into smaller pieces just like Comet Atlas did in 2020. We've already seen some evidence of outbursts that could be precursors to such an event. Or It might simply survive the encounter, lose some of its outer layers, and continue on its path, eventually leaving our solar system to wander the interstellar darkness for millions more years. Telescopes like Hubble and ground-based observatories will be tracking it non-stop, looking for any changes in brightness or structure. The data we're collecting during this brilliant passage is a scientific goldmine. It's a rare, fleeting opportunity. Once Borisov heads back out into deep space, it will dim rapidly, and we'll lose our chance to study it up close. These observations will help refine our models of comet composition and the formation of planetary systems. It also has huge implications for the future. The discovery of ʻOumuamua in 2017 and now Borisov proves that interstellar objects are not as rare as we once thought. This has energized the scientific community to develop new survey telescopes, like the upcoming Vera C. Rubin Observatory, which will be able to detect many more of these visitors. Some engineers are even designing rapid response missions that could potentially launch a probe to intercept a future interstellar guest, studying it directly with a spacecraft. Imagine that. We're living in an era where we can finally study material from other stars. So, as 2I, Borisov rounds the sun, we are watching a pivotal moment in astronomy. It's a tangible link to the vast, unexplored galaxy beyond our own little bubble. Each piece of information it gives us is a new page in the grand story of the cosmos. Whether it brightens, breaks, or just carries on, its brief visit has already changed our understanding of the universe and our place within it. It reminds us that we are part of a much larger galactic community of stars and potential worlds. What an incredible time to be looking up at the sky. Thank you so much for joining me on this cosmic journey today. What do you think will happen to Borisov? Let me know your theories in the comments below. If you enjoyed this deep dive into space, please hit the like button and subscribe for more adventures into the final frontier. Your support helps us continue exploring these amazing topics. Until next time, keep your eyes on the stars.